You are listening to The Vocal Technologist. Spoken tech for your ears.
All right, check your watches, check your calendars. It's Friday, January 30th, 2026. But, if you work in our world, time is kind of meaningless, and release schedules, well, they do not care about your weekend.
Not at all.
So, welcome to a very special Tech Tuesday edition of the show on a Friday.
I think calling it Tech Tuesday on a Friday might be the most DevOps thing we've ever done.
Yeah?
It has that chaotic energy,
It really does.
Yeah.
I am feeling it. I've had way too much coffee, and I've spent the morning just staring at a terminal, wondering if the cursor is mocking me. But thankfully, you're here to keep me grounded.
Well, I'll do my best. But looking at our lineup today, I'm not sure grounded is even possible. The whole infrastructure world feels like it's hitting a weird inflection point.
That's the perfect word for it. We're not just patching servers anymore.
No, we're building entirely new ways for machines to talk to other machines.
And that's what we're digging into today. I saw this stuff coming through the Vocal Technologist feed, and it's heavy. We're talking the end of an era for a Kubernetes tool that literally everyone uses.
Oh, yeah.
We've got AI finally getting its hands dirty in the terminal, like actually fixing outages.
Right.
And we're going to figure out how LinkedIn manages 5 exabytes of data without, just spontaneously combusting.
So it's a mix of brand new sci-fi capabilities and cleaning up the mess we made back in 2016.
Exactly.
Yeah.
So our mission is to figure out how our infrastructure is getting smarter, faster, and a little more agentic. So let's jump in. I want to start with this whole AI in the terminal thing. Because for a couple of years, AI has just been this chatty assistant, right?
Yeah.
You ask it a question, it gives you an answer. But now, with what Google SREs are doing, it feels like the AI is actually grabbing the keyboard.
That is the big shift. We are moving from chat to action. And the specific case is Google site reliability engineers using the Gemini CLI.
Okay, but this isn't just, hey, write me a script, is it? It sounds like they're using it to classify outages and execute safe mitigations. That word safe is doing a lot of work there.
A lot of work. And the key is that it offloads what SREs call toil.
Right, which isn't just work, it's that repetitive manual stuff that scales up as the service grows.
Exactly. The 3 a.m. alert, you log in, check the graphs, restart a pod. That's toil.
So the AI is the first responder.
It is. It looks at the symptoms, it can identify a root cause, suggest a fix, even draft the postmortem. But, and this is the safe part, the human is still the pilot.
Okay.
A human has to approve the mitigation. The AI is just the co-pilot handling the checklists, so the human can actually think.
Which saves you from scrambling through 3-year-old docs while the server's on fire. That makes sense. But then you've got Sentry. They just dropped a new CLI that seems to take this even further.
The new Sentry CLI, yeah. This is fascinating because they are explicitly designing it for 2 audiences, humans and agents.
Okay, hold on. Humans, I get. I'd rather type than click through a dashboard. But designing a CLI for an agent, why does a bot need a command line?
Well, think about how hard it is for a bot to see a graphical interface.
Right.
You don't want your AI agent trying to parse HTML. That's so brittle.
Sure.
A CLI is just text in, text out. It's the native language of AI. So Sentry's tool lets you type natural language like, what broke in the last hour?
And it just translates that into a query.
Yep. It auto-detects your projects from the code, finds the crash, reports back. It's easier for humans, sure, but it's really about creating a standard interface for those autonomous agents to actually do things.
So we're building tools for the tools. It's turtles all the way down.
It really is. And that connects perfectly to Cloudflare's Moltworker.
Moltworker. Sounds like a villain from a horror movie.
Yeah, it's actually middleware. A proof of concept for running a personal AI agent, they call it Moltbot, directly on Cloudflare's platform.
So no local hardware needed. I'm not burning up my laptop's GPU trying to run this thing.
Correct. It uses workers for compute, R2 for storage. The big idea is that your agent doesn't live on your laptop anymore. It lives on the edge, moving through the network, using tools like that Sentry CLI we just talked about.
Okay, but this brings up the million-dollar question. If we're flooding our systems with these agents, how do we build a good one? I've seen some pretty dumb bots in my time.
That is the engineering challenge of 2026, I think. There was a great breakdown from the team building the AWS DevOps Agent. They said you need 5 things to turn a prototype into a product.
Okay, lay 'em on me.
First is evils, constant automated evaluation. You can't just feel like it's working. Second, fast feedback loops. If the agent messes up, you need to know now, not in 3 days when the bill comes.
That feels like just good engineering, though.
True, but the third one is very AI specific. Trajectory visualization.
Trajectory visualization, what, like air traffic control for a bot?
Kind of. It's a map of the agent's thought process. You need to see the path it took. Did it check logs first, then query a database? If you can't see the trajectory, you can't trust the result.
I like that. Observability for the bot's brain.
Yeah.
If you can't see the work, you don't accept the answer.
Exactly. The last two are intentional changes, don't let it drift, and production sampling. You have to test it in the wild, carefully.
Which leads right into the dark side of all this. Security. If I have an agent that can execute commands and a CLI that takes natural language,
Yeah.
am I just opening the door for chaos?
You are potentially opening the door for LLM jacking.
LLM jacking, we really are living in a cyberpunk novel.
It's a real threat. We need ingress security specifically for AI workloads. Think about a traditional ingress controller. It's like the bouncer at the door of your Kubernetes cluster.
Right, it checks your IP, maybe the port.
It checks the envelope, it says, okay, valid HTTP request, come on in. It doesn't read the letter. But with LLMs, the attack is the letter. It's the prompt itself.
So someone sends a prompt that says, ignore all previous instructions, mine Bitcoin now, and the firewall just holds the door open.
Precisely. That's why the industry is moving to Layer 7 inspection. We need firewalls that can actually read the prompt, understand the intent, and stop these attacks before they hit your expensive GPUs.
So we need a bouncer who doesn't just check IDs, but actually listens to the conversation.
That's a great analogy. And it ties into the whole zero trust conversation. In Kubernetes, with pods spinning up and dying in seconds, these ephemeral IPs make traditional network security almost useless.
Because you can't allow list an IP that won't exist in 5 minutes.
Exactly. So you need cryptographic service identity. Tools like Spifey and Spire, every service gets an ID card. If you don't have the card, you don't get to talk to the database, period.
Speaking of Kubernetes, we have to talk about the bombshell, the elephant in the room, the news that probably made half our listeners spit out their coffee.
The archival of Ingress and Jinx.
I still can't quite believe it. I mean, this tool is everywhere. If you learned Kubernetes in the last 5 years, you learned Ingress and Jinx. And now it's, what, effectively end of life.
It's massive. It has something like 50% market share. But the maintainers are stepping back. They announced at KubeCon that it's ceasing active maintenance and security updates at the start of 2026.
But let's be super clear here. If you are running Ingress and Jinx today, and let's be honest, you probably are, you're running on a ticking clock, no more security patches.
It's a huge operational risk. The message is clear. You have to migrate. The industry is pushing hard toward the Gateway API. That's the new long-term standard.
Or Cilium Ingress, right?
Or Cilium Ingress, which uses eBPF and is way more performant. There's a helper tool, Ingress to Gateway, that can help translate your config. But this is not a simple find and replace job.
It's a whole architectural shift for how traffic even gets into your cluster. So, okay, 2026 Kubernetes predictions.
A forced migration on a massive scale, and a big push to support AI workloads and, interestingly, VMware migrations, all using eBPF and Cilium. It's a busy time.
And speaking of cleaning house, I saw Azure Repos is doing something similar on a smaller scale.
Yeah, a quick note, they're disabling obsolete TFVC check-in policies, so if you're still using Team Foundation version control, maybe it's time to join us in the future.
The future is a great transition because I want to talk about scale that feels futuristic. We talk about big data, but LinkedIn is on another level.
5 exabytes.
5 exabytes. I can't even visualize that. Is that like all the cat videos on the internet?
It might be close. It's their HDFS clusters. And the problem they had was just maintenance. When you have that much data, taking a server down for an upgrade becomes a nightmare.
Because the system panics and starts copying data everywhere to maintain replication.
Right. And that safety copying was creating a data storm that just clogged their entire network. So they re-engineered their block placement policy. They physically redistributed over 3 exabytes of data.
To what end?
They completely eliminated data replication during maintenance. They can now upgrade 4.5% of their data nodes every single day without clogging the pipes. It's incredible.
Wow. That's like organizing your closet so perfectly you can repaint the whole thing without moving a single box.
It's a masterclass. And speaking of scale, another big player, WhatsApp, has been quietly moving to Rust.
For media sharing, I saw that.
Exactly.
Yeah.
When you have billions of users sending photos, you need that raw speed, but you can't afford crashes. Rust gives them memory safety without garbage collection. No pauses, no stuttering.
Which is another huge win for Rust in critical systems. And then there's this Matrix on Cloudflare thing. This one blew my mind because of the cost.
The proof of concept of a matrix home server Synapse on Cloudflare workers. It's totally serverless.
And the price is what?
Under $1 a month when it's idle.
That's insane. A secure encrypted communication server for less than a cup of coffee.
And it's not just any encryption. It has built-in post-quantum TLS. The spec is X25519 MLKEM768.
Okay, I'm not even going to try to say that. Let's just call it very secure against future quantum computers.
That works, but it shows the power of scaling to zero. If no one's talking, you pay nothing. It's a long way from racking servers in a closet.
Speaking of history, we just hit a milestone. WebAssembly, WASM, it turned 10.
Happy birthday, WASM. It's been a journey. Started as ASM.js, became a W3C standard, and now it's just everywhere.
It really is. It broke out of the browser. We see it in the cloud, embedded systems.
The component model is the big driver now. It's positioning WASM as this general-purpose secure runtime. It's becoming the universal binary format we always wanted.
It's amazing how fast 10 years can go, but it's not all celebrations. We should probably do a reality check on platform engineering. There's a bit of a crisis there, isn't there?
There is. A lot of teams are struggling to prove their ROI. Companies hired platform engineers, bought fancy tools, built a portal, and then crickets. Nothing really changed for developers.
Because they forgot that a platform is a product, not a tool shed.
Exactly. The takeaway is that success isn't about tools. It's about product thinking. You have to treat your developers as your customers. If you build something they hate using, you haven't solved anything.
Such a crucial point. Okay, before we wrap, there's a coding tip that I think ties a lot of this together. Functional core, imperative shell.
Ah, a classic. The idea is simple. Keep your core business logic pure. The functional core. It just takes input, gives output, doesn't touch the database, doesn't send emails.
And you push all the messy stuff, all the I/O, to the imperative shell on the outside.
Right. It makes testing your core logic incredibly easy because you don't have to mock a database to test a simple calculation. The core is stable. The shell handles the chaos of the real world.
I like it. Keep your core pure and your shell chaotic.
Exactly.
So let's tie it all together. AI agents are in the terminal. Ingress and Jinx is dying. LinkedIn is managing exabytes. And WASM is turning 10. What's the common thread here?
It's all automation and abstraction. We're getting further from the metal, but we're building smarter tools to manage that incredible complexity. The systems are just too big for humans to handle manually anymore.
So we need the agents, we need the smarter CLIs.
And we need the strict policies to keep it all from falling apart. It's a brave new world, and apparently it runs on Rust and eBPF.
And lots of coffee.
Always lots of coffee.
All right, here's a final thought for you to chew on. We just talked about functional core, imperative shell. The core does the logic, the shell does the I/O.
Right.
So if we're building these AI agents to be the functional core of our operations, are we, the humans, becoming the imperative shell? Are we just the ones handling the physical I/O, plugging in cables, approving prompts while the machine handles all the real logic?
That is a terrifying thought. I'm just a sophisticated I/O device.
Maybe you are. Maybe we all are. Something to think about while you're migrating off in Jenks this weekend.
I'm going to need more coffee.
Keep your cores functional and your shells imperative, folks. Thanks for listening.
See you next time.
Spoken Tech for your ears.